A year is the orbital period of the Earth moving in its orbit around the Sun. For an observer on the Earth, this corresponds to the period it takes the Sun to complete one course throughout the zodiac along the ecliptic. In astronomy, the Julian year is a unit of time, defined as 365.25 days of 86,400 SI seconds each. There is no universally accepted symbol for the year as a unit of time. The International System of Units does not propose one. A common abbreviation in international use is A, in English also Y or A. Due to the Earth's axial tilt, the course of a year sees the passing of the seasons, marked by changes in weather, hours of daylight, and consequently vegetation and fertility. In temperate and subpolar regions, generally 4 seasons are recognized: spring, summer, autumn and winter, astronomically marked by the Sun reaching the points of equinox and solstice, although the climatic seasons lag behind their astronomical markers. In some tropical and subtropical regions it is more common to speak of the rainy season versus the dry season. A calendar year is an approximation of the Earth's orbital period in a given calendar. A calendar year in the Gregorian calendar has either 365 or 366 days. The word year is also used of periods loosely associated but not strictly identical with either the astronomical or the calendar year, such as the seasonal year, the fiscal year or the academic year, etc. By extension, the term year can mean the orbital period of any planet. For example, a Martian year, or Venerian year is the time in which Mars or Venus completes its own orbit. The term is also applied more broadly to any long period or cycle, such as the Great Year. Etymology. West Saxon a infinite r, Anglian a infinite a continues Proto-Germanic jc ran. Cognates a German jar, Old High German jar, Old Norse and Gothic all from a year, season. Cognates outside of Germanic are Avestan year year, Greek a 1/2 a micron I plus or minus year, season, period of time, Old Church Slavonic jara and Latin hornus of this year. Latin annus is from a noun ha-no, which also yielded Gothic or 3/4 n year. Both yearu and ha-no are based on verbal roots expressing movement, ha-I and ha-a respectively, both meaning to go generally. The Greek word for year, a 1/4 III, is cognate with Latin vetus old, from piuetos year, also preserved in this meaning in Sanskrit vatsar yearling, and vatsar raz year. Derived from Latin annus are a number of English words, such as annual, annuity, anniversary, etc. Per annum means each year, anno domini means in the year of the Lord. Seasonal year. A seasonal year is the time between successive recurrences of a seasonal event such as the flooding of a river, the migration of a species of bird, the flowering of a species of plant, the first frost, or the first scheduled game of a certain sport. All of these events can have wide variations of more than a month from year to year. Calendar year. A calendar year is the time between 2 dates with the same name in a calendar. A half year may run from January to June, or July to December. No astronomical year has an integer number of days or lunar months, so any calendar that follows an astronomical year must have a system of intercalation such as leap years. Financial and scientific calculations often use a 365-day calendar to simplify daily rates. In the Julian calendar, the average length of a year is 365.25 days. In a non-leap year, there are 365 days. In a leap year there are 366 days. A leap year occurs every 4 years. The Gregorian calendar attempts to keep the northward equinox on or shortly before March 21, hence it follows the northward equinox year. The mean length of the year is 365.2425 days. This is within 1 ppm of the current length of the mean tropical year, and even closer to the current vernal equinox year of 365.2424 days that it aims to match. It is estimated that, by the year 4000, the northward equinox will fall back by 1 day in the Gregorian calendar, not because of this difference, but because of the slowing down of the Earth's rotation and the associated lengthening of the day. The revised Julian calendar, as used in some Eastern Orthodox churches, also tries to synchronize with the tropical year. The average length of this calendar's year is 365.242222 days. Gregorian and revised Julian calendars will start to differ in 2800. The Persian calendar, in use in Afghanistan and Iran, has its year begin on the day of the northward equinox as determined by astronomical computation, as opposed to using an algorithmic system of leap years. Numbering calendar years, a calendar era is used to assign a number to individual years, using a reference point in the past as the beginning of the era. In many countries, the most common era is from the traditional year of the birth of Jesus. Dates in this era are designated Anno Domini, abbreviated AD, or CE. The year before 1 AD or CE is designated 1 before Christ or before the Common Era, the year before that 2 BC BCE, etc. Hence there was no year 0 AD CE. When computations involving years are done involving both years AD and years BC, it is common to use astronomical year numbering, in which 1 BC is designated 0, 2 BC is designated a 1, and so on. Other eras are also used to enumerate the years in different cultural, religious or scientific contexts. Other annual periods, fiscal year. A fiscal year or financial year is a 12-month period used for calculating annual financial statements in businesses and other organizations. In many jurisdictions, regulations regarding accounting require such reports once per 12 months, but do not require that the 12 months constitute a calendar year. For example, in Canada and India the fiscal year runs from April 1st. In the United Kingdom it runs from April 1st for purposes of corporation tax and government financial statements, but from April 6th for purposes of personal taxation and payment of state benefits. In Australia it runs from July 1st. While in the United States the fiscal year of the federal government runs from October 1st. Academic year. An academic year is the annual period during which a student attends an educational institution. The academic year may be divided into academic terms, such as semesters or quarters. The school year in many countries starts in August or September and ends in May, June or July. In Israel the academic year begins around October or November, aligned with the second month of the Hebrew calendar. Some schools in the UK and USA divide the academic year into 3 roughly equal-length terms, roughly coinciding with autumn, winter, and spring. At some, a shortened summer session, sometimes considered part of the regular academic year, is attended by students on a voluntary or elective basis. Other schools break the year into 2 main semesters, a first and a second semester. Each of these main semesters may be split in half by midterm exams, and each of the halves is referred to as a quarter. There may also be a voluntary summer session and/or a short January session. Some other schools, including some in the United States, have 4 marking periods. Some schools in the United States, notably Boston Latin School, may divide the year into 5 or more marking periods. Some state in defense of this that there is perhaps a positive correlation between report frequency and academic achievement. There are typically 180 days of teaching each year in schools in the USA, excluding weekends and breaks, while 190 days for pupils in state schools in the United Kingdom, New Zealand and Canada. In India the academic year normally starts from June 1st and ends on May 31st. Those schools start closing from mid-March, the actual academic closure is on May 31st and in Nepal it starts from July 15th. Schools and universities in Australia typically have academic years that roughly align with the calendar year, as the Southern Hemisphere experiences summer from December to February. Astronomical years, Julian Year. The Julian Year, as used in astronomy and other sciences, is a time unit defined as exactly 365.25 days. This is the normal meaning of the unit year used in various scientific contexts. The Julian century of 36,525 days and the Julian millennium of 365,250 days are used in astronomical calculations. Fundamentally, expressing a time interval in Julian years is a way to precisely specify how many days, for long time intervals where stating the number of days would be unwieldy and unintuitive. By convention, The Julian year is used in the computation of the distance covered by a light year. In the unified code for units of measure, the symbol A always refers to the Julian year out of exactly 31,557,600 seconds. 365.25 days of 86,400 seconds equals 1 or equals 1 hours equals 31.5576 milliseconds. The SI multiplier prefixes may be applied to it to form car, ma etc. Sidereal, tropical, and anomalistic years, the relations among these are considered more fully in axial precession. Each of these 3 years can be loosely called an astronomical year. The sidereal year is the time taken for the Earth to complete one revolution of its orbit, as measured against a fixed frame of reference. Its average duration is 365.256363004 mean solar days. Today the tropical year is defined as the period of time for the ecliptic longitude of the Sun to increase by 360 degrees. Since the Sun's ecliptic longitude is measured with respect to the equinox, the tropical year comprises a complete cycle of the seasons. Because of the biological and socio-economic importance of the seasons, the tropical year is the basis of most calendars. The modern definition of mean tropical year differs from the actual time between passages of, for example, the northward equinox for several reasons explained below. Because of the Earth's axial precession, this year is about 20 minutes shorter than the sidereal year. The mean tropical year is approximately 365 days, 5 hours, 48 minutes, 45 seconds. The anomalistic year is the time taken for the Earth to complete one revolution with respect to its apsides. The orbit of the Earth is elliptical. The extreme points, called apsides, are the perihelion, where the Earth is closest to the Sun, and the aphelion, where the Earth is farthest from the Sun. The anomalistic year is usually defined as the time between perihelion passages. Its average duration is 365.259636 days. Draconic Year. The Draconic Year, Draconic Year, Eclipse Year, or Ecliptic Year is the time taken for the Sun to complete one revolution with respect to the same lunar node. This period is associated with eclipses. These occur only when both the Sun and the Moon are near these nodes. So eclipses occur within about a month of every half-eclipse year. Hence there are 2 eclipse seasons every eclipse year. The average duration of the eclipse year is 346.6200758883 days. This term is sometimes erroneously used for the draconic or nodal period of lunar precession, that is the period of a complete revolution of the Moon's ascending node around the ecliptic, 18.61281592 Julian years. Full moon cycle. The full moon cycle is the time for the Sun to complete one revolution with respect to the perigee of the Moon's orbit. This period is associated with the apparent size of the full moon, and also with the varying duration of the synodic month. The duration of one full moon cycle is 411.78443029 days. Lunar year. The lunar year comprises 12 full cycles of the phases of the Moon, as seen from Earth. It has a duration of approximately 354.37 days. Muslims use this for celebrating their Eids and for marking the start of the fasting month of Ramadan. A Muslim calendar year is based on the lunar cycle. Vague year. The vague year, from annus vagus or wandering year, is an integral approximation to the year equaling 365 days, which wanders in relation to more exact years. Typically the vague year is divided into 12 schematic months of 30 days each plus 5 epagomenal days. The vague year was used in the calendars of ancient Egypt, Iran, Armenia and in Mesoamerica among the Aztecs and Maya. Helical year. A helical year is the interval between the helical risings of a star. It differs from the sidereal year for stars away from the ecliptic due mainly to the precession of the equinoxes. Gothic year. The Gothic year is the interval between helical risings of the star Sirius. It is currently less than the sidereal year and its duration is very close to the mean Julian year of 365.25 days. Gaussian year. The Gaussian year is the sidereal year for a planet of negligible mass and unperturbed by other planets that is governed by the Gaussian gravitational constant. such a planet would be slightly closer to the Sun than Earth's mean distance. Its length is 365.2568983 days. Basilian Year. The Basilian Year is a tropical year that starts when the mean Sun reaches an ecliptic longitude of 280 degrees. This is currently on or close to January 1st. It is named after the 19th-century German astronomer and mathematician Friedrich Bessel. The following equation can be used to compute the current Basilian epoch: B equals 1900.0 plus / 365.242198781. The TT subscript indicates that for this formula, the Julian date should use the terrestrial time scale, or its predecessor, ephemeris time. Variation in the length of the year and the day. The exact length of an astronomical year changes over time. The main sources of this change are the positions of the equinox and solstice points with respect to the apsides of Earth's orbit change, the first because of precession, and the apsides because of the long-term effects of gravitational pull by the other planets. Since the speed of the Earth varies according to its position in its orbit as measured from its perihelion, Earth's speed when in a solstice or equinox point changes over time. If such a point moves toward perihelion, the interval between two passages decreases a bit from year to year. If the point moves towards aphelion, that period increases a bit from year to year. So a tropical year measured from one passage of the northward equinox to the next, differs from the one measured between passages of the southward equinox. The average over the full orbit does not change because of this, so the length of the average tropical year does not change because of this second-order effect. Each planet's movement is perturbed by the gravity of every other planet. This leads to short-term fluctuations in its speed, and therefore its period from year to year. Moreover, it causes long-term changes in its orbit, and therefore also long-term changes in these periods. Tidal drag between the Earth and the Moon and Sun increases the length of the day and of the month. Since the apparent mean solar day is the unit with which we measure the length of the year in civil life, the length of the year appears to decrease. The rotation rate of the Earth is also changed by factors such as post-glacial rebound and sea level rise. Numerical value of year variation, mean year lengths in this section are calculated for 2000, and differences in year lengths, compared to 2000, are given for past and future years. In the tables, a day is 86,400 SI seconds long. Summary: 346.62 days, a Draconic year, also called an eclipse year, 353, 354, or 355 days, the lengths of common years in some lunisolar calendars, 354.37 days, the average length of a year in lunar calendars, notably the Muslim calendar, 365 days, a vague year and a common year in many solar calendars, 365.24219 days, a mean tropical year for the epoch 2000. 365.2424 days, a vernal equinox year for the epoch 2000, 365.2425 days, the average length of a year in the Gregorian calendar, 365.25 days, the average length of a year in the Julian calendar, 365.2564 days, a sidereal year, 366 days, a leap year in many solar calendars, 383, 384 or 385 days, the lengths of leap years in some lunisolar calendars, 383.9 days, a leap year in some lunisolar calendars. An average Gregorian year is 365.2425 days equals 52.1775 weeks equals 8,765.82 hours equals 525,949.2 minutes equals 31,556,952 seconds. A common year is 365 days equals 8760 hours equals 525,600 minutes equals 31,536,000 seconds. A leap year is 366 days equals 8784 hours equals 527,040 minutes equals 31,622,400 seconds. The 400-year cycle of the Gregorian calendar has 146,097 days and hence exactly 20,871 weeks. Symbol: There is no universally accepted symbol for the year as a unit of time. The International System of Units does not propose one. NIST SP 811 and ISO 80000-3 suggest the symbol A, taken from the Latin word annus. In English, the abbreviations Y, or IR are sometimes used, specifically in geology and paleontology, where Chi, Mi, Bi, and similar abbreviations are used to denote intervals of time remote from the present. Symbol A, NIST SP 811 and ISO 80000-3 2006 suggest the symbol A. In English, the abbreviations Y and R are also used. The Unified Code for Units of Measure disambiguates the varying symbologies of ISO 1000, ISO 2955 and ANSIX 3.50 by using R for R and at equals AT equals 365.24219 days for the mean tropical year, AJ equals AJ equals 365.25 days for the mean Julian year, AG equals AG equals 365.2425 days for the mean Gregorian year, A equals 1 AJ year, a definition jointly adopted by the International Union of Pure and Applied Chemistry and the International Union of Geological Sciences is to use annus, with symbol A, for year, defined as the length of the tropical year in the year 2000, A equals 365.2421925 days equals 31,556,925.445 seconds. The notation has proved controversial. It conflicts with an earlier convention among geoscientists to use A specifically for years ago, and Y or A for a one-year time period. SI prefix multipliers. For the following, there are alternative forms which elide the consecutive vowels, such as kilanis, meganis, etc. Ka is a unit of time equal to 1,000 years. This is typically used in geology, paleontology, and archaeology for Holocene and Pleistocene periods where a non-radiocarbon dating technique, i.e., ice core dating, dendrochronology, uranium-thorium dating, or VAV analysis, is used as the primary dating method for age determination. If age is primarily determined by radiocarbon dating, then the age should be expressed in either radiocarbon or calendar years before present. Ma is a unit of time equal to 1 million years. It is commonly used in scientific disciplines such as geology, paleontology, and celestial mechanics to signify very long time periods into the past or future. For example, the dinosaur species Tyrannosaurus rex was abundant approximately 66 ma ago. In astronomical applications, the year used as the Julian year of precisely 365.25 days. In geology and paleontology, the year is not so precise and varies depending on the author. Gēar is a unit of time equal to 109 years. It is commonly used in scientific disciplines such as cosmology and geology to signify extremely long time periods in the past. For example, the formation of the Earth occurred approximately 4.57 Gēar ago. Ta is a unit of time equal to 1012 years. It is an extremely long unit of time, about 70 times as long as the age of the universe. It is the same order of magnitude as the expected lifespan of a small red dwarf star. Pa is a unit of time equal to 1015 years. The half-life of the nuclide cadmium-113 is about 8 pascals. This symbol coincides with that for the pascal without a multiplier prefix, though both are infrequently used and context will normally be sufficient to distinguish time from pressure values. A is a unit of time equal to 1018 years. The half-life of tungsten-180 is 1.8 A, symbols Y and A. In astronomy, geology, and paleontology, the abbreviation A for years, and YAR for years ago are sometimes used, combined with prefixes for thousand, million, or billion. They are not SI units, using Y to abbreviate English year, but following ambiguous international recommendations, use either the standard English first letters as prefixes or metric prefixes or variations on metric prefixes. These abbreviations include, use of IR, and BIR is deprecated in modern geophysics, the recommended usage being MA, and GAR for dates before present, but MY. For the duration of epochs. This ad hoc distinction between absolute time and time intervals is somewhat controversial amongst members of the Geological Society of America. Note that on graphs using year units on the horizontal axis, time flows from right to left, which may seem counterintuitive. If the year units are on the vertical axis, time flows from top to bottom, which is probably easier to understand than conventional notation. Great years, equinoctial cycle. The great year, or equinoctial cycle, corresponds to a complete revolution of the equinoxes around the ecliptic. Its length is about 25,700 years, and cannot be determined precisely as the precession speed is variable. Galactic year. The galactic year is the time it takes Earth's solar system to revolve once around the galactic center. It comprises roughly 230 million Earth years. See also. References, notes. Further reading, Fraser, Julius Thomas. Time, The Familiar Stranger. Amherst, University of Massachusetts Press. ISBN A0-87023-576-1. OCLCA 15790499. Whitrow, Gerald James. What is Time? Oxford, Oxford University Press. ISBN A0-19-860781-4. OCLCA 265440481A.